Here's a pretty standard time travel problem, I guess you'd call it. And the question states 1 year passes for someone on a ship traveling at 99.9% of the speed of light. How many years pass for an observer on Earth? So, when we recall our time travel formula, we know that the time on Earth equals the time of something, the something we're dealing with in this case is the ship, um, over the square root of 1 minus the velocity of that something over the speed of light constant squared. So let's write down what we know. So we're solving for t, and our t0 is 1. They tell us 1 year's passed. And the way we're going to express the velocity is we have to divide this by 100. It's essentially just moving the decimal places twice to the left. So we're going to express the velocity as 0.999 c times the speed of light. So now let's just plug things in and see where we get. So t time on Earth equals 1 over the square root of 1 minus 0.999 c squared over the speed of light constant squared. And now you'll see why, if you watch the derivation video of the formula, now you'll understand why we did this weird algebra and we left this denominator irrational. We did the weird factoring. Because now if you look over here, well, how are we going to kind of expand this right here? Well, we're going to have 0.999 squared times c squared. So the reason we pulled that c squared out over in this derivation and we put this here is because now look, we have a c squared over a c squared, and the property is multiplication right here. So that means we could cancel these out. And now what we're left with is something not multivariable. So t is our only variable now, and we could just plug this business right here into the calculator. So that was the logic behind that. It's good to know the why behind things. So now we just have 1 minus 0.999 squared. I shouldn't have crossed that squared off up here. Alright, so, and this approximates to 22.4 years. And that's pretty incredible when you think about it. So, this is saying 1 year passes for this person on the ship traveling at this very high, very high speed. And so for them, that 1 year passed, and on Earth, 22.4 years has passed. So when they get back, things are much different.